We have f of x and we have g of x. Okay? When we have this written, it's going to usually look like this and say f of g of x. The one that is closest to the x is the one that is going to go in for f. Okay? So this is my g of x. Specifically, there it is. So g of x is going to go in place of f. So we're going to start by writing f. Let me make this a little bigger. So I'm going to say 5, which is right here. And instead of writing the x, I'm going to put a set of parentheses. Okay? Plus 2. Now, since g is next to the x, I'm going to take that whole g of x term, 2x minus 1, and put it down in place of the x. So 2x minus 1 goes inside the parentheses. Okay? And now we just need to simplify. All right? So as I look at this, how can I simplify this expression down here? What would I need to do? Yeah, we're going to distribute that 5 with the 2 terms on the inside. So 5 times 2x is going to be 10x. 5 times minus 1 or negative 1 is going to be negative 5. The 5 doesn't distribute with the 2, and then you just have the plus 2 here at the end. Well, here you have your 2 constants. So you are going to combine those like terms, and your final answer is going to be 10x minus 3. And that's your final answer. Okay? So let me back up just a little bit and talk about this composition, because I feel like I kind of went over that quickly. So a composition, okay, is taking one expression and substituting, bless you, substituting it in for x of a second expression. Okay, a composition, that's what we call it. Taking one expression and substituting it in for x of a second expression. And they are both entirely different from each other. You will not get the same answers. So here, even though we have the 2 same expressions, we have f of g of x. For letter B, we have g of f of x. So which function is closer to the x here for letter B? Which function is literally closer to the x here? F. So we are going to take all of this f of x and we are going to replace it in g of x. So first of all, g is first, so we're going to start with g. And instead of putting the x, we're going to put parentheses. So we're going to say 2, instead of x, we're putting parentheses, minus 1. Now, I'm going to take that f of x, and I'm going to substitute that in for the x there. So f of x is 5x plus 2. So I'm going to substitute 5x plus 2 right here. Stay off. Let's put that down. So how would I simplify here? What would I need to do? Distribute. Yes, so you're distributing the 2 with these two terms here. 2 times 5x is 10x. 2 times 2 is 4. I don't distribute with the -1. I just put that at the end. And then you need to check, do I have anything else that I can simplify? Yes. You've got 2 constants here. So 4 minus 1 is 3. And the 10x stays in front. And I don't know that it will always necessarily even have, that same first term. I don't think you could count on that. But they are 2 entirely separate types of problems. Okay? So the main idea is that you have to see which function is closest physically to the x, and then you are going to substitute that entire expression in place of the x of the first one. All right, so let's take a look at the next page. Did everybody have enough time to write that down? Now, I think on your homework, sometimes, it could be f of g of x, could be g of f of x. I think on the homework, we only do it in one direction. Okay? So, this says, given that f of x is equal to 5x minus 3, and g of x is equal to this. Well, which one, when we say f of g of x is closer to the x? Which one is closest to the x? So I'm looking right at this, f of g of x. Which one is closest to the x? G. So you are going to take all of that g of x, and you are going to replace all of that in for that x. Okay? All right, I want you to try to do that on your own right now, because this is a check, just to see if it makes sense to you. Maybe if I go like this. This is called a composition. All right. Let's see how you did. So g of x is closest, or g is closest to the x. So that means I am going to start with the very first one, and I am going to rewrite that. But instead of the x, I'm going to put a set of parentheses. So 5 times parentheses minus 3. Now I am going to substitute g of x, that whole thing, in for the set of parentheses. So that is 2x plus 1. And when I simplify, I get 5 times 2x, which is 10x, plus 5 times 1 is 5. And finally we have minus 3. When I look at this, I know I can combine those two terms, and I can get 10x plus 2. Anyone happen to have 10x plus 2 as their final answer? Good. That's not too bad, right? All right. Let's take a look at this. This is maybe just shown a little bit differently. And again, that is not a multiplication. Notice here it's a little bit raised. It doesn't have to be raised. I think it's usually right here down in the middle. But that is the sign for composition right here. So which one, the function of g or the function of f, is closest to the x? F. Okay, so we're going to keep all this together, keep that together, and you're going to write the function of g first. So you're going to write this first, and you're going to replace the x with parentheses. All right, so we're looking at g of x. This is what we're doing first. And instead of x, I'm going to put parentheses here. I'm going to say parentheses plus 5. Okay, then I'm going to take that f of x, and I'm going to replace it here in that set of parentheses. 2x. So in this case, is there any other simplifying that I need to do? Do I have to distribute it all? No. Are there any other numbers that I have that are common that I can join together? No. So your final answer is just 2x plus 5. That's it. Any questions on that? Okay. That is all that we have for today. So this is called compositions. So you need to look for which is closest to the x. Take that expression or that function, substitute it in for x of the other function. So homework. Homework number 1. We only have 2 for this module. Homework number 1 is due tomorrow. Okay, we have time right now. I want to see everybody with their papers out. We still have about, I don't know, 6 minutes. You can get a lot done in 6 minutes. Okay.